Myself, Dr. Kavita Singh, Associate Professor in Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss a course called as Remote Sensing and GIS. So from this course, our topic will be Introduction to Photogrammetry. So before entering to Introduction to Photogrammetry, let us discuss about what is remote sensing and what is GIS. So these are two different terms, remote sensing and GIS. So remote sensing is different and GIS is different, but it is always studied together. These are both integrated to each other. So what does it mean? Remote sensing means it's like obtaining the information of any physical objects on the ground surface without any physical contact. From a distance, we are trying to get the information. So like we use satellites, we use aeroplanes, we use parachutes to just capture the ground information without touching the ground or any of the object on the surface. So this is about the information how we gather, and later we just integrate with GIS. So GIS is called as Geographical Information System. So it gives the information about the geographical features on the Earth's surface. Whatever we collect through remote sensing, either it is remote sensing, either it is photogrammetry, we just collect that information, and GIS helps us to display the information and get the information to the users. Whoever the users are, they are able to get the information through GIS. So this is about the course. Now let us enter to the topic called as Introduction to Photogrammetry. So photogrammetry is about obtaining the information like aerial photos through aerial or through ground or through any kind of survey. We are able to just gather the information without touching the object. This photogrammetry is also kind of a remote sensing, which we are able to get the information without touching the object. So introduction to photogrammetry, let us move on to the contents. What are the topics we are going to discuss today? So first thing is like definition of photogrammetry, types of photogrammetry, photogrammetry for engineering, types of aerial photographs, and application of photogrammetry. So let us discuss about, first of all, what is the definition of how do we define photogrammetry. Like photogrammetry is basically, it is about understanding or learning about the aerial photos through different platforms. So here if we see in this image, we have here different platforms. One is ground platform, the other one is airborne, and one more level if we see, that is also airborne, and another level we have. So we have three different levels which are airborne platforms with a distance. Now if we see here, this is a ground platform. Ground platform means obtaining the photographs with the help of camera, with the help of tripod or camera or a theodolite, we are able to capture the information of the ground. Now if we move on to the little more above, we have 100 to 300 meters above if we move. So here our platform will be the air, and our vehicle will be the aeroplane, and it has a device called as camera which will capture the information with a distance of 100 to 300 meters. So it's a very short distance from the ground, so the capturing of the information of the ground, it will be more, clarity will be remaining more, right? When we move on to the next step, here again we have 300 meters to 3 kilometers. This airborne sensor like the aeroplanes will be capturing the information with the help of a camera. So the clarity will not be too much good about this. But here if we see, the clarity will be more because it is taking from a less distance, that is 100 to 300 meters. Right? Now again if we move on to the more upper side, we have one more altitude called 3 to 10 kilometers. So from 3 to 10 kilometers, the airborne sensors will be capturing the information of the ground. So this is the surface which is going to be captured. So this all are called as photogrammetry. This all are called as photogrammetry. That means they are capturing the photo, they are capturing the image without touching the object in the presence of light. Photo means light, so it will be in the presence of light, they are able to capture the information. So now we have one more platform here called as spaceborne sensor. So this spaceborne is also a kind of remote sensing, but here, except this 3 and 4, this will be having a platform, space platform, and the satellite will be carrying the sensor, and they will be capturing the information of the ground in the space platform. So these are all different platforms where the images are captured without touching the object. So these are all remote sensing. So photogrammetry is one of the part of remote sensing where the objects are captured without touching the object. Now if you define photogrammetry, photogrammetry is the science and technology of obtaining reliable information about physical object and the environment through the process of recording, measuring, interpreting photographic images and patterns of electromagnetic radiant energy. So this all, why we call it as photogrammetry. Photo means presence of light. Sunlight is required to capture all kind of information. So photogrammetry is only possible whenever the sunlight is available. So nighttime it cannot capture the information, right? So this was the different platforms of photogrammetry. Next, if we see different types of photogrammetry. So what are the different types of photogrammetry? Types means it will be aerial, as we have seen in the previous slide. One was the ground-borne, one was the space-borne, and other was the airborne. So now if we see here types of photogrammetry, we have aerial, terrestrial, close range. So these are the three different types of photogrammetry. So aerial means series of photographs of an area of a terrain in sequence using the precision camera. So here the platform will be air and the vehicle will be aeroplane, and it will be having a sensor called as camera, which will be capturing the information in a sequence, information of the terrain in sequence using the precision of the camera, right? So this is aerial photogrammetry. Now we have terrestrial photogrammetry. Terrestrial means ground. So this kind of photogrammetry is like taking the photos of the ground surface from a ground platform, right? So platform will be ground. So here the platform will be ground, right? And here the platform will be air. Air is the platform for aerial, and for terrestrial, ground is the platform. Now, photos taken from a fixed and usually known position on or near the ground with the camera axis horizontal or nearly so is called as terrestrial photogrammetry. Now you have close range photogrammetry. So close range photogrammetry, this also is a photogrammetry which is captured from a platform called as ground. Okay, so this is also captured from the ground platform. So camera close to object being observed, most often used when direct measurement is impractical. So this two type of photogrammetry, terrestrial and close range, this type of photogrammetry is taken from the ground platform, and terrestrial means with some distance of 1 kilometer or 2 kilometer or 3 kilometer, whereas close range means it's very near to the camera, like with a distance of 1 meter or 2 meter. So we use this close range photogrammetry for capturing a nearby information without touching the object. So these are the three types of photogrammetry. Now when we see about this images, so this is of aerial photogrammetry, just now what we were discussing about. So here the platform is air. Now one image, this is the image which is captured from the air with a distance of 3 kilometers, with a distance of 4 kilometers or 10 kilometers, right? So this is the image which is captured. So we can see the clarity here. We can see water body over here. Water body is there. Here greenery is there. Here we can see the buildings very clearly. We can see the road very clearly here. I can see the road here. and this is also roll. So as this image is very clear, we can say that this type of photogrammetry is aerial photogrammetry, and it is taken from a very short distance. We can say that 3 kilometers or 7 kilometers or 10 kilometers. So that's why the clarity remains. If the distance will be more than 10 kilometers, then the clarity will be somewhat less, the resolution of the image will be somewhat less, so we will be unable to differentiate the features of the ground surface. So we have to maintain the camera precision, and just we have to capture the information so that the information will be so clear for the interpreter, because later with the help of this photo, the measurement of the building and the measurement height of the building can be measured. If the photo clarity is more better, we are able to measure the height of the building, and we are able to measure the different types of objects in the image with the help of the image. So this is how the image is captured in the aerial photo. Like this will be the flight, and this is the flying height. So suppose this is the ground. This is the ground. So in air, the flight will be going in this direction, either east to west or west to east, right? So while moving to a direction, it will click the photos. So it will capture the ground. Suppose one photo it has clicked here. So this is the photo number 1. We can see here we have an overlapping photo here. So we have photo number 1, photo 1. Now we have photo 2, right? Photo 2. And we have photo number 3. So it has clicked 3 photos, photo 3. So photo 1, photo 2, photo 3 with a overlapping area. So like that, in a direction it keeps on clicking a photo in a same direction with the overlapping area, so that no area should be missed. So overlapping is must in the aerial photogrammetry. So because if it will not go with this overlap, then there is a chance of missing a small area which will be kilometers on the ground. So here we have a individual aerial photograph, here we have an overlap, and this is the center of the image, right? So this is called as aerial photogrammetry, the images which are captured from the air. Now if we come to this two other types of photogrammetry, we have terrestrial photogrammetry, we have close range. Terrestrial, close range. So terrestrial photogrammetry is a photogrammetry, as I said before, it is the photo taken from the ground with a more distance. Like we have a tripod here, we have a tripod. Along with that, we have a theodolite here, theodolite, or it may be a camera on the tripod, right? And there are some points over here which to be captured. So these are some points to be captured. So from this distance itself, from this position itself, it is going to capture this point, this point, this point, this point, this point. Okay, all the points it is going to capture from a fixed location, right? Fixed location. So this is called as terrestrial photogrammetry. So this is also possible when the sunlight is available. In night time, we are unable to take this kind of images. So terrestrial photogrammetry is from the ground and in the presence of sunlight. Now here we have close range photogrammetry. Close range photogrammetry, you can see here, we have a tripod here, and there is a camera fixed over here. There is a tripod here, there is a camera fixed over here, and this is going to capture a very nearby information, like with a distance of, suppose this area to be captured, this area to be captured, 1 meter, 2 meters, right? So these are 3 types of photogrammetry. One is aerial, terrestrial, close range. So basically, if we classify broadly, so photogrammetry are 2 types only, that is aerial and terrestrial. But if we classify into 3 classes, aerial, terrestrial and close range we have. Now, photogrammetry for engineering. How it is helpful for engineering? So photogrammetry is the process of measuring images on a photograph. As we have discussed this before, it is a process of measuring images. We can even measure the images. When the image clarity is more, we are able to measure the images. We are able to measure the height of the building. We are able to measure the height of the object. And photogrammetry is a technique used for studying and precisely defining the shape, dimension and position in the shape of any object using mainly measurements taking over one or more photographs of that object. So it is helpful in taking the or defining the shape, defining the dimensions, position and space of any object using mainly the measurements taken over one or more photographs of the object. So as we know, modern photogrammetry is also uses radar imaging, radiant electromagnetic energy detection and X-ray imaging called remote sensing. So if we before also I told you photogrammetry is a kind of remote sensing. So remote sensing is a more advanced photogrammetry. We call it as modern photogrammetry. So remote sensing, like with the help of the space platform, we are using satellites to capture the information in the form of images, right? Now, if you see here, photogrammetric surveying or photogrammetry is a branch of surveying in which maps are prepared from photographs taken from the ground or air stations. So, we take this photo images with the help of photogrammetry, and later we are able to prepare our own maps by taking the measurements on the photo itself with the help of a scale. With an advancement of the photogrammetric techniques, photographs are also being used for interpretation of geology, classification of soils and crops. Later we can, this aerial photogrammetry is very much helpful in our interpretation to any users or any defense purpose, forestry, water resources, because the image clarity will be more, so it will be more helpful in the interpretation of the different kinds of soils, interpretation of different kinds of crops, classification of different kinds of crops, and interpretation of geology features like different kinds of rocks, different kinds of minerals. So it is very much helpful for the people, those who are going to want the information about this kind of things. So it is the science of making measurements from photographs, especially for recovering the exact positions of the surface points. So it also helps to make the measurements from the photographs. As I said before, also we can just measure the height of the building, height of the objects, different kinds of objects on the earth surface without touching the object. So photogrammetry is so much helpful in measurements, making measurements and getting the exact positions of the surface points. Now, let us discuss the subtopic called as types of aerial photographs. Types of aerial photographs. What are the different types of aerial photographs? We are having two types of aerial photographs. Like in aerial photogrammetry, we have, as I told. So in this, we have two types of aerial photographs. That is vertical photograph and oblique photograph. So what is vertical photograph and what is oblique photograph? These are two things which this is the output of the aerial photogrammetry in the form of photographs. Now, vertical and oblique. These are the two things. Vertical means exactly vertical to the ground surface. Like if flight is here, if the camera optical axis is here, and the ground surface is here. This is the ground. Let us say this is the ground, and here is the area to be covered. This is the area to be covered. So from this optical axis exactly vertical to the ground is known as vertical photograph. Okay, it is known as vertical photograph, which is exactly vertical to the ground, right? Now we have oblique photograph. So this we have two types. One is low oblique photograph, one is high oblique photograph. So what is low oblique and what is high oblique? First of all, let us understand what is oblique photograph. Okay, so oblique photograph is photographs taken at an angle called as oblique photographs. So in vertical photographs, you see a vertical photograph is one which has been taken with the camera axis directed toward the ground as vertically as possible. So this is called as vertical. Now oblique photograph is photographs taken at an angle called oblique photographs, and oblique photographs is of two types. Oblique means it is not vertical exactly. It is not vertical exactly. It is slightly tilted. So if the camera is somewhat here, so your photo will be somewhat like this. Okay, it's not vertical to the ground exactly. So this will be the ground. This will be the captured area. So we have two types here, low oblique aerial photograph and high oblique aerial photographs. So what is low oblique aerial photograph? Is a photograph taken with a camera inclined about 30 degrees from the vertical. 30 degrees from the vertical. In this type of photograph, horizon is not visible. What is horizon? I'll tell you in the next slide what is horizon. First, let us understand what is low oblique photograph and what is high oblique. So, a low oblique photograph is a photograph which is taken from the angle inclined with 30 degrees from the vertical. It's called as low oblique. Now, high oblique photograph. The high oblique photograph is taken with a camera inclined about 60 degrees from the vertical. So, in this type of aerial photograph, you can see horizon is visible. Here we can see here horizon is not visible. Here you can see horizon is visible and the inclined angle is 30 degrees in the low oblique, and here in inclined angle is 60 degrees and horizon is visible. Now let us see what is exactly horizon is. Now here we can see here vertical, as I said in the previous slide. So vertical looks exactly vertical to the ground. So this is the ground. This is the ground to be captured. So it is exactly vertical to the ground. Here is the camera. So it is not at all tilted. Here we have two types again. You can say vertical two types. That is true and tilted. Okay. True and tilted. So true means exactly vertical. There is no tilt at all. And tilted is less than, we can say less than 3 degrees tilt. Only less than 3 degrees tilt. Is called as, this two type of photograph is called as vertical. Now let us see what is oblique. Here I was telling you low and high. So low, as we have seen in the previous slide, 30 degrees inclined. So here is the area to be captured from here to here, and here we have an optical axis. Okay, optical axis, and here is the camera. So this is the exact ground position, and it is tilted up to 30 degrees angle, and so the area coverage will be little bit more. In vertical, the area coverage will be exactly vertical. We can see only top of the object. We can't see the side of the object. We can see only the top view of the object. Okay, top view of the object. Whereas in the low oblique photograph, we can see side of the object and top of the object. Only the difference here is there is no horizon. No horizon. Here in this high oblique photograph, the field of view and the angle inclined will be 60 degrees. Okay, and the field of view will be more wide. So the field of view is up to here to here. Now the area coverage from here to here, it will be there. So here we have horizon here. Okay, horizon is visible. Horizon is visible means we can see, horizon means, let me tell you what is horizon. Horizon is the line which separates sky and the ground. Sky and the ground. That means in a photo, the area will be visible is ground as well as the sky. Now same thing you can see here in the grid form. So vertical means only the top we can see, and low oblique means top and side we can see. Okay, top and side, but there is no horizon, only the objects we can see here. Now in high oblique we can see side, top as well as horizon. Okay, so this is the horizon line. This is the horizon line which you can see here. This is the horizon line from here to here. Okay, so here this is the sky and this is the ground. So in a photo we are able to see the sky, we are able to see the ground also. Okay, so that's why it is called as high oblique photograph with the angle inclined of 60 degrees. Okay, this was about the vertical, low oblique and high oblique. Right. Next, we can see here same types of photo taken from the camera. Now this is the vertical one where you can see the only top view. Okay, which is exactly vertical to the ground. Now here we have low oblique. Low oblique means you can see here a lot of forest area you can see, and tree top you can see and side also you can see. Okay, water body is there, and here some objects are there. You can see the top, you can see the side, but there is no horizon. Okay, no horizon means there is no sky visible in this, right? Whereas if you see the high oblique photograph, you have a clear sky visible here. Okay, sky, and this is ground. Okay, so this is the horizon line which separates. This is the horizon line which separates sky and the ground both, right? So it is the wide view it captures with an inclined angle of 60 degrees, where you can see the top, you can see the side. Okay, you can see the sky, you can see the ground. Here there is no sky, here there is no sky. So I hope you understood what are the different types of photo. Vertical means exactly vertical, and in vertical we have true and tilted. True means exactly vertical. Tilted means less than 3 degree tilt. Now in low oblique, high oblique, low oblique, there will be no horizon and the tilt will be up to 30 degrees and there is no horizon line. Whereas in the high oblique photograph, there is a horizon line visible and the tilt is 60 degrees tilt. Okay, so these are the different types of aerial photographs. Now here the actual picture we can see here. So this is a vertical photograph which is taken from the aeroplane with the help of the camera with a distance of 3 kilometers to 5 kilometers we can say, where you can see very clearly the top of the building, right? All the top of the building, top of the tree, right? Top of the road we can see here, and the top of all the trees you can see the top, all the buildings you can see the top. There is no horizon line and there is no side view of the object. So whatever object which is easily very clearly visible in this photo, you can see all the buildings top view we can see. All the buildings top view we can see, right? There is no horizon line. Here some vehicles are standing here, right? You can see here very clearly. So this is very clear picture from an aerial photograph which helps us for the measurement of the height of the building. But here we cannot see the side of the building, side of the object. So here somewhat it will be difficult for measurement. So we use very slight vertical photograph or low oblique photograph for the measurements. Okay, so this is about the vertical one. Now if you see there is one more photo here. So this is low oblique photograph. So in this low oblique photograph you can see, as we have discussed before, that there is no horizon but top view and the side view is visible on the photo. So if you see here there is a top of the building here, top of the building here you can see the top, and even along with this we can see the side of the building, right? Side of the building, side of the building, right? So here whatever objects it is visible in this side is visible, right? So top and side of this vehicle, top of the vehicle. So this is called as low oblique photograph, but there is no horizon line. Okay, there is no horizon line. Right. Next we have a clear picture of high oblique photograph. High oblique photograph. So as I said before, high oblique photograph is having a horizon line. This is about the horizon line. Very clear picture. Now you can see the side, top. Okay, top here, side. Right. Trees also you can see the side. You can see the top. And you can see the sky here, right? So this is the tower side, top, right? Building top, building side. So these are the images, these are the photos which are taken from a high oblique camera, right? So this is the about high oblique, low oblique and vertical photographs. Next, what are the applications? If we come to the applications of photogrammetry, what are the field applications of photogrammetry? So it is used to conduct topographical survey or engineering surveys. What is topographical survey? Topographical survey means, topography means the geographical features on the earth's surface. Whatever geographical features we see on the earth's surface comes under topography. So it helps us for digital survey. Right? We need not go to the ground. With the help of the photo, we are able to do the survey with the help of the software. So it is very much helpful for the topographical survey. Now we have a suitable for mountain and hilly terrain with little vegetation. Now, manually, if we want to go to a hilly terrain and try to measure the area and we try to get the information, it is somewhat a very difficult task. So, with the help of photogrammetry, we are able to get the images in a mountainous terrain and hilly terrains where we are unable to reach. In the remote areas we are unable to reach, we are able to get the information with the help of photogrammetry. Now, it is used for geological mapping, which includes identification of landforms, rock types, rock structures. So it is used for geological mapping. So it helps us to find out, as the images are very much clear, photos are very much clear, we are able to find the geological structures and different kinds of landforms, different kinds of rock types, and it helps us to find the rock structures too. And later it is helpful in mapping, geological mapping, different types of thematic mapping we can do with the different kinds of rock and different kinds of rock structures. Now it is used for project demanding with higher accuracy, since it provides accurate measurements. So few projects which needs very accurate measurements, projects like in the construction field also, if we see, while construction of the road, construction of the building, construction of any kind of dams, if we want to go for this kind of accurate measurements, we need to refer this aerial photos, because it gives a very good quality images and very clear pictures, which is really helpful for the measurements on the aerial photo itself. So instead of going to the ground, instead of going to the field, we are able to take this aerial photos. We are able to take the aerial photos and we are able to help measure the objects. Now it is used in the urban and regional planning applications. What is urban planning? What is regional planning? Urban planning means to plan a city, to plan a region. It is very much helpful for the planners, for the decision makers. They are going to just take these images. They are just going to make different kinds of planning with the help of these kind of images. They are able to know what is the condition of that present land, and later what can be that kind of decision they can take based on this kind of images. So urban plan, regional planning, it is very much useful because it gives a very clear information about the water resource, very clear information about the forest resource, and it gives you the very clear information about how much land is vacant, how much land is occupied, and land use, land cover information also it will help. It is very much helpful to get that kind of information, which helps the planners to take a decision and go for a new kind of construction works. So used mostly in planning, designing, in transport planning, bridge, as I said before also, mostly planning, designing, transport planning, and bridge, pipeline, hydropower, urban planning, security and strategic planning, and disaster management, most important, disaster management. So these are all these are all fields where the aerial photogrammetry is very much helpful. First of all, planning, as I said, it gives the first-hand information to a planner to just plan the city, plan the urban areas, so how much area is land you utilize, how much area is with the land cover, and which kind of land can be utilized for which purpose, the transportation purpose, for bridge purpose, for pipeline purpose, or for hydropower, or for urban planning, security, strategic planning. This all kind of information it gives you with the help of an aerial photo. Now, disaster management is very much important in this kind of all applications. So, disaster management means, as we know, what is disaster management? Disaster is a sudden event. It can occur anytime, any moment, without intimating to us, right? So, we have to manage this kind of disasters with the help of aerial photo, as the aerial photo will give us the clarity, clear picture. It gives us a scenario where to be constructed, which kind of houses to be constructed, where to be shifted, which area is safe, which area is more vulnerable. That all kind of information we have with the help of aerial photo, and it helps us to manage the disaster, which will help us to reduce the losses in the future. And natural resources. Natural resources management means natural resources. Water resource is a natural resource. Forest resource is a natural resource. Okay, and different kinds of resources which helps us to manage how much area to be properly managed and all. This is very much helpful in disaster management and natural resource management. City models planning. How to plan a city, what kind of model, if we go for a construction work, what kind of planning can be done, and conservation of archaeological sites, etc. So even it helps us in the conservation of archaeological sites. So these are huge applications of photogrammetry, which is very much helpful to us in planning a city or to plan an area with a proper planning. The planners are very much, they use this kind of photo images to go for a proper land use planning, right? So for today, we just stop this lecture, right? And in the coming topics, we are going to discuss about the type of overlaps and what is the flight line direction, how the geometry of aerial photograph looks like, what are the different photos we see, what is different kinds of flight line direction, photo 1, photo 2, what is mosaic. This all information we'll just talk in the next lecture. So for today, that's all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.